Hello everyone, this is Abhishree presenting you the fourth module Process Control. In previous modules, we have learned different concepts about process identification, forking a child, race condition and others. In this module, let's know more about process controls. First, changing user ID and group ID and interpreted files. We know that the privileges for a process or a program mainly depends on its user ID and group ID. That is, if the process wants to access some resources of the computer, it has to be having appropriate user ID for which the privileges are accessible. So, when a program need additional privileges or need to gain access to resources that are not currently allowed to that process, we need to change the user ID to the appropriate privilege or access. Similarly, when a program needs to lower their privileges or it has to prevent the access to certain resources, then again they have to change the user ID without the privileges or ability to access the resources. Before saying how to change the user ID and group ID, let me briefly explain the types of user ID that the process can have. It can be real user ID, effective user ID, or saved user ID. Real user ID is basically owned by the owner of the process, and effective user ID is similar to real user ID, but it is not the owner of the process but still has the privileges that a real user has. Saved user ID is used when process is running in elevated privileges. That is, it has to change back to the original user ID it had when the process has completed. Now let us see how to change user ID and group ID. There are mainly two functions used to do the same. They are set UID, which is used to change the user ID, and set GID, which is used to change the group ID. These two functions will return 0 when the user ID has been changed successfully and returns -1 when error occurs. There are some rules to be followed while changing the user ID or a group ID. They are: if the process has super user privilege, that is, if it is running as root, then the set UID function will set the real user ID, effective user ID, and also the saved user ID to UID. That is, it will update all three user IDs to the one we are specifying. If the process does not have any super user privilege, but UID equals to either the real user ID or the saved user ID, then the set UID sets only the effective user ID to UID. The real user ID and the saved one are not changed. If either of these or if neither of these two conditions is true, then the value returned will be 1, where the error permission will be set. These are the two variations of set user ID program function which we studied earlier. First one is set REUID. This is the method used to swap real user ID and effective user ID. We can supply the value 1 as optional argument for any of the argument to indicate that the corresponding ID should not change. And also, using this method, an unprivileged user can always swap between real user ID and effective user ID. The same applies for group ID. Then the second variation is set EUID. As the name itself suggests, this is used only to set the user ID and group ID only by effective user ID or effective group ID. This is the syntax to use this method. An unprivileged user can set the effective user ID to either real user ID or set saved user ID. That is, only the effective user ID can be changed. This is the diagram that summarizes all the functions that I have explained in previous slides. As we can see, the set UID, that is set user ID, will set the real user ID, effective user ID and saved user ID to UIDs. Similarly, the other two variations of set UID are set REUID and set EUID, where set REUID is used to swap between real user ID and effective user ID, while set EUID is used only to change the effective user ID to UID. Now let us study about interpreted files. We have already learnt about this in our previous modules. Let me brief it out here. So these are the text files that begin with the line of the form this: hash, exclamatory mark, path name and optional arguments. We know that the path name is usually the absolute path name because no operations are performed using this path name. And the example, the best example we have seen about it is hash exclamatory slash bin slash sh, where we are specifying that the program, the file has to be executed in bash shell, and also the space between the path name and the exclamatory is optional. This is it for my topic. Thank you.